This is Alexander Buzan, OV252, recording for task 1 for the biomechanics test to be handed into Luca if this somehow gets lost. What I intend to treat in physical therapy is a common problem, that is back pain, which can be caused by a variety of reasons, either work, stress, or many reasons, many of which can't be identified straight away, however they do happen. As to how I'll really compete, well, not compete, but just work to solve this problem is with a commonly solved problem is just to have massage, and which I've developed a mechanism for here. Now the full video of it working can be found in a video attached with this one. What the basic principle is that is dual purpose, so circular to vertical motion, so if you spin it this way, they'll translate into vertical movement. Again, see the video for it working. So a motor or hand cranked can be applied here, and this can move laterally or vertically to move along the spine, or it can be done from vertical to circular, so either hand crank or an electric motor applied here, and as soon as it moves up, it will cause a circular motion to move here. That can be rubbed just on the back or just on the sides of the spine. So as we can see here, the purpose is just to have around about 2 seconds. Well, as for a massage, it has to be slow. You don't want to go too fast to cause any further injuries. And so around about 2 seconds for a full revolution to take place. And so it takes about, the full amount of time it will take is 2 seconds. So 2 pi divided by 2 would be pi radians a second, or 180 degrees. Just to do 180 degrees per second, 360 degrees for 2 seconds. And as we can see here, seeing as we do have only four links and 4 pairs, using that equation, 3 brackets n minus 1 minus 2, well, we can pretty much conclude that we have 1 degree of freedom, which, as I mentioned before, we can either stick a motor just up here, or just down here, either circular to vertical or vertical to circular. Either way around, the purpose that is dual purpose. And so these are just the measurements done. This is to scale, by the way, just to let you know. Move on to the next page. And so we can pretty much model this. Well, displacement we can model just from the center. The center here, how it moves from circular to vertical. We'll be going up and then down and back up again, over and over and over again. And so we can model that with just a graph and how it moves, and pretty much can be modeled as a sine graph. Now it can't just be sine x. As you can see, displacement just negative and positive along the time axis of 6 seconds. However, as I said, it can't be just sine x. Just have to multiply by 50 to get 50 sine x, but even that's not enough, as we need to factor in a unknown k factor just to multiply it. Because if you actually look at a 50 sine x graph, it won't actually cross at 1, 2, 3, 4 every second, really. And so just use a bit of mathematics. Just seeing here, we can conclude that k can essentially be 180 degrees, or pi. And so with this equation, 50 sine 180x, we can essentially model the displacement that way. If we can model the displacement that way, then we can also differentiate it to get the velocity, which can be seen here, 50 pi cos pi x. And then, seeing as x is a value of time, we can put in, any number. But as far as, minimum velocity will be just 0. As you can see on the last page, at the maximum velocity, it will just be, hang on a second, display, hang on a second, yeah, it would be 0.5 seconds, and we can conclude that seeing a cos, the biggest value of cos can be 1, so we can conclude that 50 pi, the maximum velocity can be 50 pi millimeters a second, and by further differentiating d squared y dx over dx squared, which can be modeled as 50 pi squared sine pi x, and again using the same logic that we did here, conclude that the maximum acceleration can be 50 pi squared, 50 pi squared millimeters per second squared, and that maximum acceleration occurs just when it's at its peak, so just here. Also, just correction, the maximum velocity will not be there, it will just be at these crossing points here. That's when it's moving further down, because when you think about the circular motion, it's going like this, and when it reaches just the end, it's going to stop and then go back up, and the maximum velocity will be here. And that really concludes it. Thank you for watching.